Chapter 4. Summarizing Data, Measures of Variation. Besides the measures of central tendency, we need measures to describe the variability of the data. In the following, we will consider four measures of variation: the range, the variance, the standard deviation, and the coefficient of variation. Suppose that a test was given in two sections of a math course. The scores of students are given in the table. It is easy to calculate for both sections. The mean, the median, and the mode are equal. The common value is 60 points. This information may suggest that the two sets of data are identical. Of course, this is not the case. This tells us that we need other types of measurements to have a good understanding of the distribution of the data. The range is one such measurement that can be used to describe the variability in a set of data. The range of a set of data is defined to be the difference between the largest value and the smallest value. The range for section 1 is 8. The range for section 2 is 60. Thus, there is more variability in section 2. In general, the range is a quick and easy measure of spread, and it's usually not satisfactory because it uses only two extreme values in a set of data. The variance is an average of the squares of the deviations of the measurements from their mean. If we have a set of n values, then the mean x bar is given by dividing the sum of the measurements by n. To find the variance, we find the deviation of each measurement from the mean, then we square each of these deviations. The sample variance is given by dividing the sum of the square deviations by n minus 1. The sample variance, s squared, is an unbiased estimator of the population variance, sigma squared. The sample standard deviation, denoted by s, is computed by taking the positive square root of the sample variance. If we have a population of finite size uppercase N and population mean mu, then the population variance, denoted by sigma squared, is obtained by finding the sum of the squared deviations for each value from the population mean and dividing the result by capital N. The population standard deviation, denoted by sigma, is obtained by taking the square root of the population variance. In many cases, it is easier to use a different but equivalent formula to find the sample variance. This formula requires the calculation of two sums: the sum of all values in the dataset and the sum of all squares of all the values in the dataset. The numerator is the formula and is usually denoted by s sub xx. Again, to find the sample standard deviation, take the square root of the sample variance. If the sample standard deviation of a set of data is small, the values are concentrated near the mean, and if the sample standard deviation is large, the values are scattered widely about the mean. This can be expressed more formally by Chebyshev's theorem, which states that the proportion of the data that must lie within k standard deviations of either side of the mean is at least 1 minus 1 over k squared. If the distribution has the general shape of a cross-section of a bell, then we have the following empirical rule: 68% of the values fall within one standard deviation of the mean. 95% of the values fall within two standard deviations of the mean. And 99.7% of the values fall within three standard deviations of the mean. This figure illustrates the empirical rule. The number of standard deviations that a value is from the mean is called the standard unit, or z-score. Each value in a set of data has a standard unit computed by subtracting the mean from the value and dividing the result by the standard deviation. A standard unit gives the standard deviation units about the mean. For example, if a value has a standard unit equal to 2, then their value lies 2 standard deviations above the mean. And if a value has a standard unit equal to -1, then their value lies 1 standard deviation below the mean. The standard deviation depends on the units of measurement. This makes it difficult to compare sets of data with different units of measurements. For this reason, statisticians use instead the coefficient variation, denoted by v, and given by dividing the standard deviation by the mean and multiplying the result by 100%. The coefficient of variation has no units, and it expresses the standard deviation as a percentage of what is being measured. The following table illustrates the typical way in which data is grouped in a frequency table. There are k classes with class marks x sub 1, x sub 2, up to x sub k, and the corresponding frequencies are f sub 1, f sub 2, up to f sub k. This is the formula that we use to compute the standard deviation when we have data grouped in a frequency table. In this table, the distribution of the percentages of students who are bilingual in elementary schools is given. We start by finding the class marks for the 5 classes. Using the formula for the mean from Chapter 3, we see that the mean is 7.8%. Using the formula for the standard deviation, we see that it equals to 5.66%.